Hi everyone, welcome back to my channel and welcome back to my series Learn with me Data Science. This video covers regression modeling part. I am Vanshika Verma. So starting with regression modeling introduction, it is a statistical technique used to establish a relationship between a dependent variable which can be target and one or more independent variable that can be features. So it is of three type. So first is simple linear regression, second is multiple linear regression, and third one is polynomial regression. So simple linear regression is models the relationship between a single feature variable and the target variable using a straight line. Multiple linear regression models the relationship between multiple feature variables and the target variables using a linear equation, allowing for the analysis of multiple factors. And polynomial regression models the relationship between feature variable and the target variable using a curved line, allowing for the analysis of linear non-linear relationship. So let's jump into the Python implementation of regression modeling. So this is the code for model evaluation. The first part is importing libraries and preparing the data. In this, firstly, we are importing the Panda library for data manipulation, NumPy library for numerical computation, and importing the test and split function from sklearn model, sklearn for splitting data into training and testing sets, and importing the linear regression class from sklearn for linear regression modeling. And at last we are importing the mean squared error and R2 square score functions from sklearn for evaluating model performance. And here we are creating a sample data set and into feature and sample data set where data and all these entities defines a dictionary containing sample data for a regression modeling, and df equal to pd dot data frame in data creates a panda data frame from the dictionary, and we are splitting the data into features and target. X equal to df select the age and mileage uh, column as feature of x, and y equal to df price select the price column as the target variable of y. This code does not split the data into training and testing set using train test split, but it set up the data for a regression problem. The next step, the next part of the code is building the model and evaluating. So in this code, we are first splitting the data into training and testing set. Uh, the first line split the data into training and testing set using train test split x and y equal to 0.2 allocate 20% of the data for testing and 80% for training, and random state 42 set the random seed for reproducibility. Now we are creating and training the linear regression model equal to linear regression. Create a linear regression model using linear regression class, and model dot fit trains the model on the training data using fit. Now we are making the prediction. Y pred equal to model dot predict x test makes prediction on the test data using predict. And now we are evaluating the model. MS equal to mean square error. Calculate the mean squared error between the predicted and actual value using squared error, and R2 equal to R2 score. Calculate the R squared value, which is coefficient of determination, using R2 score, and then print this print function print the MSE value of two decimal places, and this print function print the R squared value with two decimal places. So this is the output for this code, which interpret that the mean squared error is 1738281.25. Uh, so this measures the average square difference between the predicted and average value. So in this case, the MSE is approximately 1.7382821.25, which suggests that the model is making prediction that are on average about 1317 unit away from the actual value. So R square is here 0.86. So R square is a measure of the proportion of the variance in the dependent variable and is predictable from the independent variable. A higher R squared value indicate better model performance. So it means the model is explaining more of the variability in the data. And in this case, the R square value is approximately 0.86, which suggests that the model is explaining about 86% of variability in the data. Overall, this result suggests that the linear regression model is performing reasonably well with an R squared value indicating that it is explaining a significant proportion of the variability in the data. However, the MSC value indicate that there is still some room for improvement in terms of the accuracy and the prediction. Now move to the demonstration of stepwise regression. So in this code, we are performing stepwise regression. In starting in first, we are importing states model library from statistical modeling, and x with const equal to sm dot add constant x adds a constant term to the feature x to allow for an intercept term in the regression model equal to sm dot ols fits an ols regression model to the data using the ols class from states model, and print model summary prints a summary of the model including coefficient, standard error, t values, p values, and r squared. And we are performing backward elimination manually. Here, while model dot p value dot max starts a loop that continue until all p value are below a certain significant level, which we are set it as 0.05. Here, exclude feature identifies the feature with the highest p values, which is the least significant feature, and x with const drops the least significant feature from the data. Model equal to sm dot ols refeeds the ols regression model using the updated data. Print f dropped prints a message indicating with a feature was which feature was dropped, and print model summary prints a summary of the updated model. So this code performs backward elimination, a feature selection technique that iteratively remove the least significant feature until all remaining features are significant. The resulting model is more parsimonious and easier to interpret. This is the whole code for performing regression model with model evaluation and stepwise regression. That's all for this video. Meet you in my next video, which is on the topic dimension reduction. Till then, keep smiling, keep exploring. Bye bye.